All right. Well, then I guess I'm live. Good morning to everyone. It's good to see a lot of familiar faces and some new ones as well. And like Doug said, out of 6 of them, I've only missed one. And, well, I can't blame anybody but him because he conflicted with my training. So it's good to be back, and I'm happy to do this paper. And my forte being electrical, very small slice when you get right down to it of what the UltraProbe is capable of. But in my world, a very important slice. We not only use this for diagnostics, but it is part of our everyday safety protocol. And as you can imagine, doing any type of work on energized electrical equipment, there's an inherent danger to opening those enclosures up, particularly today with the arc flash considerations. We don't want anybody getting hurt. So I've called this decoding high-frequency SOSs. We've learned over the years, using the UltraProbe, there are very specific signatures for the types of faults we are interested in on the electrical equipment. And it's a very important part of our analysis procedure, making good judgment calls using this. And we've refined it over the years and still working with Doug and Mark and Gary to even refine this further to help us out. So we need more and more, if you think about it. Electricity is truly the lifeblood of anything you touch, feel, see, or hear these days. Would everybody agree with that? Nothing works without electricity. And the thing that's lacking most, and I heard it said earlier, is maintenance. The aging infrastructure, the cutbacks at different facilities, all that relates to is less and less maintenance is being performed on the electrical equipment that we rely on. And a lot of people think, well, there's nothing really moving in the electrical systems, but that's not necessarily true. When you think of alternating current, there are stresses put on components, conductors, and parts 60 times every second or 50 times if you're from overseas. So this is stresses that eventually degrade and break down equipment. And there's an old saying where I come out from says, the minute you install a piece of equipment, it begins to fail. And I truly believe that. So the demands of today are higher than at any point in the past, and the reductions in the maintenance budget ultimately lead to failures, as I said. Sooner or later, it is going to happen. So factoring in human interaction and errors that are inevitable when you're talking about human beings, because we're infallible, adds another dimension to that risk. Preventing failure and increasing uptime, reducing the unplanned outages, is on everybody's top to-do list. Well, how do you accomplish that if you cut maintenance budgets? You have to get more and more precise as time goes along, so it's set in motion more unconventional methods of accomplishing this. And most recently, I would say over the last 10 to 15 years, that means we're not doing maintenance a traditional way with shutting the system down, going through all the components, and putting a wrench or a screwdriver on every connection, which I believe creates problems more than it does correct problems. So the philosophies have changed over time, and even with a great maintenance tool, the user has to be trained and knowledgeable in how to use that tool. I don't care what you're using. It could be an infrared camera, an ultrasonic probe. It could be an MRI machine if you're a physician. If you don't know how to use it, you're not going to be very effective. So training and knowledge is very important. So this year, I don't know if anybody has seen the paper. It's far more detailed than the presentation. But looking at a few examples of things that have come back to me from our organization. And as Doug said, we have a presence in 25 different countries now and growing. And that includes over 500 technicians that are doing this type of work, even in non-English speaking countries. So that's a challenge for us to communicate it, but it's working very well. So a simple, what I call a who, what, when, where, why, and how approach helps us streamline the process. So identifying who among the equipment is susceptible for ultrasonic faults. Having a good working knowledge of how components work is very important to making accurate judgment calls. You need to have a competency level on your application in order to be effective. Knowledge of what to be listening for. Everything has different tonal qualities and orally sounds different depending on what you're listening to. Would you agree with that? Creating conditions when certain faults are most likely to occur. In my world, it's there, depending on the component you're working with, it could be load dependent, it could be environmentally susceptible, it could be interaction from workers in the facility. Whatever the case may be, you need to know when the highest likelihood of the faults occurring would be. Knowing where to apply the different modules. We use all the modules, the magnetic, the contact, the airborne, long range comes into play, and in certain applications we're certainly using the parabolic microphone. So setting up the instrument correctly and applying that is important. Being mindful of why certain anomalies are occurring. You have to be able to distinguish the sound you're listening to. James said it best, you got to listen to your equipment, because a lot of things sound very similar in electrical, and being able to pick out the small subtle differences allows you to increase your precision. And then having an action plan on how to proceed once you uncover a fault that could lead to a failure. The first example here, I was actually involved with this personally on the back end, so it's pretty cool. And this was in July of 2009. My customer in Charleston, South Carolina, contacted me with a recording he had made on a 13.8 kV switch. And this is in a hospital in downtown Charleston. And for those not real familiar, with U.S. geography, and that Charleston's one of the oldest cities in the country, and all the buildings there are no different. They're very old, and with a hospital, you certainly have a high degree of a need for no interruptions. So this is the physical picture of the switch here, and the red arrow is pointing to the area in which the recording was made initially. And that was using the contact module. And this is just a schematic layout of what the room is like. Now, the interesting part of this room is it was on the 6th floor of the hospital with no access to install or remove the equipment that was in this room. It was a block wall that would need to be blown out, for lack of better words, if one were to replace equipment. And being a hospital, there's a lot of redundancies. This particular lineup was the one we're talking about. Directly opposite of that lineup was one just like it that were tied together. So you can imagine on a 13,000 volt switch, if you have a failure, what I've learned in electrical is failures aren't typically contained to the component that fails. There always seems to be ancillary damage. And certainly the redundancy could have been jeopardized would a failure occur. And there's only about 8 feet in between these things. So it's unit substations. You have a load switch, a transformer, and then a lineup of switchgear that serves the loads within the hospital. So the initial recording that he had sent to me, and if we can click the picture here, it was obvious something was going on that wasn't normal for this type of equipment. And when you looked at the spectrums, I mean, the FFT, Mark and I have talked a lot about this over the years, and there's only certain information, at least in my application, that I'm going to get out of the FFT. One of them is it either tells me it is electrical in nature or it's not. And on certain faults, I look for certain frequencies and the noise content in between there, but not much else. The time domain is more important to me in electrical, to be honest with you. So looking at these two side by side, and unfortunately you couldn't hear it, the one thing about the time domain electrical, you have that band of white noise throughout, and if there's any discharges going on, you'll see these spikes or excursions throughout that spectrum. And that's somewhat evident, but you have to slice and dice it, to use Mark's term, to really take a peek inside. And what we're looking at here is variations in between the amplitude of those discharges, as well as variations within the spacing between it, meaning the timing. And that tells us two things there. There are discharges occurring, and there's no pattern relative to the electrical sine wave on when that's occurring. So that's a very common signature. And it's what I call non-uniform in nature, is how I tell our guys. It's a tracking event. But this is a 13.8 piece of equipment, so there's another component to that you'll see in a minute. The shutdown was planned on September 2nd, once this was done, and a follow-up visit I had already had on the schedule to do some training with my customer, so I got to go down there with him, and he made the suggestion, why don't we go to the hospital and take a peek at this again? And I don't think this will play either, will it?
Give it a shot.
Probably not. We're not going to try and play them anymore. We went back on this visit just by random chance and decided to take a listen, and the positioning of the contact module where the intensity level was highest had changed. It was now no longer in the upper left-hand corner. It was more toward the middle on the left-hand side, which was interesting. But the tonal quality had changed. The decibel level had changed. And in electrical, I mean, the decibel level, unlike motors and bearings that we talked about a little bit earlier, for me with electrical, it's only telling me how close I am to the source of an emission. It's not a gauge for severity on how bad something is. So looking at these spectrums, the FFT, it's got some noise content. There are a couple 60 hertz harmonics. But in the time domain, you can see that the intensity has increased, as well as the frequency of occurrences or discharges. And dicing that up or magnifying it really illustrates that point. You can see the excursions are much higher. They're far more compacted, meaning the discharges are occurring more often and at greater intensity levels. Without a doubt, it becomes tracking. And as part of, you guys have heard it called destructive corona. And with anything over 1,000 volts, I don't need to tell anybody, you have an ionization process taking place where a high frequency noise is created, but it's very predictable. And it's predictable because the stresses create that ionization, and it occurs every 16 milliseconds. So the FFT looks real nice with the 60 hertz harmonics. The time domain is very linear and uniform. But when the nitrates are formed and it breaks down insulators, now over that 360 electrical degrees, you begin to have discharges anywhere on that sine wave. It gets less uniform in nature. When the equipment was opened up, after they had gone back with a planned shutdown and a very tight time window, it was very clear that the analysis was not incorrect. And on the ceramic insulators, you can see the byproducts of destructive corona, the nitrates or white powder that we look for that will ultimately break down that conductor insulation. Even here, the discharge was more evident. This is one of the conductors running through a Bakelite phase barrier or insulator. It had actually had visual evidence of carbon indicating an electrical discharge across this Bakelite. It's only a matter of time before this ends up failing. And that was evident there. This is the transformer enclosure, and even on the structural support, there was evidence of nitrates. So this has been going on for quite some time. It's obvious it's in need of some housekeeping, but it's not the type of component you like to open up, energize, and work on. It gets kind of dangerous at those voltage levels. So we knew that we were correct in our assumption without ever opening the equipment, and it never could have been identified without using the ultraprobe and knowing how to analyze that stuff properly, convincing the customer we do need to shut it down. And that's what they did. And as you can imagine, in a hospital, it is a logistical nightmare to coordinate shutting anything down. But we were able to accomplish that, get it open, and clean it up because the switch is so old there's not replacement parts available, but they're on order, and there's a planned shutdown coming up. And that's a wider angle view there of the transformer, just giving you an indication of the physical layout inside. It's a very large unit substation. So the proper repairs were not done at that time, but it was cleaned up enough to prolong the inevitable. But the parts are on order, and they're going to be planning a shutdown to do that correctly. As far as the contractor goes, how do you think he looks to that customer, that facility manager now? Without seeing anything, preventing an outage like this, possible loss of equipment, nobody else is going to go in there and work on our equipment at this point. That I can assure you. So it was a real good find. And it certainly would have been a lot better if you'd have heard the files. The second one here is actually from our friends overseas in Birmingham, England. And technician mine, Mick Lamburn, was at a customer site, and they asked him on another pad mount transformer just to take a listen with the ultraprobe because there was structural movement apparently taking place, causing a shift in the foundation of the transformer. And this was connected using bus duct or bus trunking on top of the unit here. And you can see that the supports holding that trunking up are bent. And this caused what? This caused the duct to get in a bind on that elbow. Well, I can assure you that's not a good situation for that. So they took a listen, and you can see here it's twisting and contorting this on an 11 kV side of the transformer. So it's not a good situation right here. He listened to this, and of course it won't play, so I apologize. But it was clear that there was some type of electrical discharges taking place, most likely tracking. Of course, they didn't shut it down yet. And when we analyze this, what's the FFT show us? Nothing. Not in this case. It's very wanton. But the time domain, once again, has that signature or footprint that we're on the lookout for. We have the excursions. We have variations in the amplitude or the intensity of the discharges. And there's not a pattern to the spacing in between these, or the timing, if you will. And I think in the paper it goes into a little more detail on how that relates to an electrical sine wave. When you zoom in on that tool, just take a slice in time on there, it becomes even more clear how nonlinear these excursions and timing are on the events taking place. So without a doubt, there's something occurring that is in the process of being analyzed or coordinating a shutdown so they can get inside. He went back a second time a couple months later just to see, do we have any deterioration on this particular event that we saw? And you can see it was same settings, same measurement point, same sensitivity setting, same pressure on the instrument, drastically different on the time domain, isn't it? The FFT still isn't showing us a whole lot. But with the time, when you compare them side by side, the content is a lot more rich on the time domain, and slicing it up, it's clearly evident it has deteriorated. And since I've done this presentation, I believe they have taken the step to shut this unit down, open it up and inspect it, because it's a brand new unit. And what Mick told me, I don't know the results of the inspection yet because it's very recently, but the concrete foundation below, I guess there was a steam line and it had caused the concrete pad to buckle, forcing the unit up. So certainly that would have caused a failure, but once again, using these tools, you can see the amplitude changes and the timing changes. And I just put the two recordings side by side here. In my world, comparisons are everything. Yes, sir. We have a question.
No heat signature?
None. Well, if you go back and look at the duct, I mean, I don't want to talk about infrared here, but it's a shiny piece of metal. So in order to see any type of heat signature, it'd have to be really, really hot. But in this case, no, there wasn't. Okay?
What voltage was it again, Joe?
11 kV. Yeah, it's 11 kV to 400 volt transformer. And this is, I did throw a slide in here, I guess. This is something Mark did several years ago. We were in Australia trying to help our guys understand how these events relate to electrical sine waves, because they understand electrical sine waves better than they do frequency analysis and time domain. And what this shows is where do discharges occur on the electrical sine wave relative to that 360 degrees and 16 millisecond time base. As you can see, when the tracking occurs, it's no specific point on that sine wave, which leads to the types of time domains we see. As those discharges occur, you see the excursion on the time domain. They're not going to be evenly spaced because we don't have uniformity between those discharges. And as it gets worse, you're going to see that occur more frequently over the sine wave, which compacts the time domain view. And I just say there's not a discernible pattern. That's why it makes the time domain look the way it does. And as I said with Mick, they have taken a peek at this and got the shutdown. I haven't got the results back yet, but if anybody wants to know what it is, I'll let you know when I find out. The third one here, again, is from the United Kingdom, and this one is from the London area on a 1600 amp switch. It's in a plant that manufactures these ceiling tiles that they put up. And as you can imagine, it's very dusty, very dirty, very noisy. And this switch was one of the main units that fed plant equipment. So here's a physical picture of it right here. And audibly, what Gavin, the technician, had told me was the room was completely silent. You could not hear anything. So he took his airborne probe initially and went around all the door seals like we teach people to do, just to ensure there wasn't nothing going on, and picked up an anomaly. And then ultimately moved on to the contact module. Because of the type of process, he sent me this image of one of the fire extinguishers hanging in the room, and you can see all this dust is accumulating on everything. And the reality is, if it's on the outside like this, I can guarantee on the inside of the equipment, it's going to be just as dirty. And is this type of dust, could that become an electrical conductor? Under the right conditions, it can. And once it becomes a conductor, you have a path to ground, which leads to an arc flash explosion or failure. This is his actual view here that he sent me, making the recording, which obviously we're not going to be able to listen to, unfortunately. But you can see it's yes. I'm amazed. So, I mean, forget anything else. From a tonal quality standpoint, do you think that's something that we want to hear from a switch? Most likely not. And at 11 decibels, is it going to be worse if the dB level shows 40? No, it just means I'm closer to it. I don't know how severe it is yet. I don't know what it is yet. We have to analyze this. And, I always tell our guys, and I preach it in electrical, don't use decibel level the way you do in other applications. You cannot gauge severity using dB. You have to use the spectralizer. And I stand by that statement no matter what. Here's the spectrums off of that. And as you can see, and now being in the UK, we're on a 50 hertz system, so it's a different harmonics frequency setting. We have a lot of noise content, but is there really any frequency peaks here that you can see? Nothing distinguishable, but the time domain has that footprint again. A lot of excursions, differences in the spacing, meaning differences in the timing. Slice it up or zoom it in, it becomes far more apparent that the frequency of occurrence, how often this tracking is taking place, is pretty good here in a quarter second. I mean, it's very high, the amplitude, meaning the intensity is large, and it's getting more compacted. So that means it's happening more often. Physically, what I advised him to do, we like to triangulate down where the highest dB level is, only to tell us the general area where the source of the emission is originating from. And I told him, use a grid method. Quadrant the switch off with tape and take your measurements there and plot your readings. And it's easy to isolate down the highest intensity level, means you're closest to the source. Knowledge is power, right? You want to know where that is. And that's essentially what I did. You can see on the left-hand side, that's the contact measurements. On the right-hand image, he's using the airborne with the rubber focusing cone. Now, after I wrote the paper, he sent me some subsequent images, and this was an infrared image he had taken from the screen. If I go back one slide here, everybody can see the screen on the right-hand side by the airborne. I mean, that's an air vent. And he just decided to take an infrared picture from that, and this is what he saw. Does that really tell you anything? Not really. And with tracking taking place, because that's what's going on here, does that eventually develop a thermal signature with tracking? Does it create heat? Yeah. It does when it reaches ground and it becomes a high-resistant current flow. I mean, current flow in electrical does create thermal energy. Hard to see from this vantage point. But he was pretty fortunate. He had rear access to this particular switch and opened it up. And as you can see right here, 85 degrees Celsius on the one pole, right in the area where he had quadranted off with tape, found the highest intensity level. There was enough dust from this process to create a high resistance path to ground, allow current flow, and raise the temperature 85 degrees Celsius. Now, how many people in here speak Celsius? All right. For the rest of you, why don't you with electrical? Nothing's rated in Fahrenheit. But for your benefit, 85 degrees C is approximately 190 degrees Fahrenheit. And, oh, by the way, we can't see the direct source of where this is coming from. So is that temperature true? No. I guarantee it's higher at the source. So it's at least 85 degrees Celsius, meaning we got a high resistance path there. It's going to fail. There's no doubt in my mind, and there was no doubt in Gavin's mind. But he would not have taken the steps to look at this image in this fashion without the ultra probe. And an outage was scheduled. They're going to clean this up. It's going to get dirty again. They got to do some other things engineering-wise in this room to prevent that from happening. But again, a failure was avoided on there. So the contractor's eyes, you know, he couldn't get it done quick enough. He has subsequently done this maintenance, and it's all taken care of. Time is of the essence in a situation like this, folks. You know, we talked about symptoms earlier. I heard somebody mention that. That's all infrared is in electrical. I like the folks who will buy a camera, go out, hey, I'm Joe Thermographer, and I find everything with it, right? The reality is, when it comes to electrical, heat energy, thermal signatures, they're only a symptom of something else going on. It's one tool I use to help me find the root cause of a problem. So a manufacturing facility like that, is there going to be a business interruption cost if that switch fails? Who knows what that is? It hasn't been quantified yet. Can you find the parts right away? Who knows? But if it fails, it's going to be far more costly than the route that was taken. The last example here is going to come from a place in Indiana that I was working, and typically you don't consider this as a possible source of ultrasound. But what I always tell these guys, you know, when it's arcing, tracking, corona, you think of higher voltages than I'm going to talk about here. That's simply not the case with today's equipment. Manufacturing standards, in my opinion, the quality of the equipment we're using these days is not as good as it used to be in days gone by. When you talk about circuit breaker contacts and that, the ingots that are being used to manufacture that, the silver coating thicknesses are microscopically thin. They don't last the way they used to. And when they break down, you get these events taking place. This is a fruit facility, as I said, and it's the third year of a maintenance agreement in which my customer has been doing maintenance for this organization and has the entire history. And this component has been there forever and a day. And they haven't found any issues with it in the past. Maintenance is regular here. So is it possible that things change from one year to the next? What are some reasons you may observe changes in a facility you've been working in for a number of years? Anybody have? New equipment is one thing. What else? Housekeeping. New personnel. You know, interaction. Anything can change. That can alter all the dynamics and metrics of the equipment we've been looking at year after year. And this example is going to be no different. It's a simple 30 amp 2-pole circuit breaker. Big deal, right? It's a 30 amp breaker. Is that really important? Yes, it is, because you got to take into consideration what, Mark?
Fire.
Fire's one, but what is it feeding?
Interrupt.
Yeah. I mean, the load that it's serving, if it's only a space heater and it's the middle of summer, maybe it's not as critical as what we really have here, in which it is feeding the computer room for this facility, which houses the entire inventory control system, ordering, the time clock stuff that's in there, payroll. Now it becomes a pretty important component, does it not? And that's all it was right here. This says that, oh, that's a duplicate slide. I apologize. One of the things I was doing on this visit was training. These guys, there was a transition at this particular contractor location, so we had new technicians, and I was out working with them in the field just to assist them in getting proficient at using all the tools. And one of the things we did was we broke out the contact module just to go through this panel because we had some time to kill, to be honest with you. And when he did, let's cross our fingers this will play. This was on the top pole, that 30 amp circuit breaker. Now, how many folks in here, show of hands, have used the Ultra Probe on electrical circuit breakers? Contact module. Does that sound like something you'd want to hear? Yes. Should be very quiet. Agreed? Nothing. Silent. Not even the air rushing sound like we have on the bearings, right? So this here, obviously, just from a tonal quality standpoint, there is something going on internally on the breaker. And as you can see, it's a Westinghouse breaker, so probably not manufactured to the highest standards. It's very concerning considering the load I told you it was feeding, right? If this device fails and it shuts down their server room And this is a really interesting facility. There were forklifts running back and forth. I almost got hit 6 or 7 times. You know, they run you down. They don't care. They're flying through there trying to move stuff and load trucks. This computer room goes down. All that comes to a grinding halt. Time is money, right? So it became very important. The Spectrum's on here, and this is a great training opportunity because we were able to do this real-time field as it was happening. So the technician got a great opportunity to put these into action. What does the FFT show us here? Not a lot of anything, to be honest with you. Yeah, it's got some 60 hertz spikes, and there is some frequency content in between those 60 hertz harmonics, but the time domain, once again, becomes the telltale sign. You can see right here that there's obvious excursions. They're not perfectly uniform throughout that recording. And when you slice it up, I love this view. And Mark, I'm glad you turned me on to doing this because it really has altered my approach to training. But you look at just a quarter-second slice of this recording, ladies and gentlemen, and you can see, without a doubt, that there's no pattern here, is there? The amplitudes change or alter throughout this slice. The spacing in between it, meaning the time where it's occurring, has no pattern whatsoever. It is clearly tracking without a doubt, and that breaker will ultimately fail. And we brought this to the attention of the customer, and they changed that out immediately. So it's a good training opportunity. It's a great way to illustrate from a visual standpoint what these electrical problems look like, if you will. So no one can dispute that, and the bottom line is it does not matter what voltage level you are dealing with. You can find ultrasonic faults when it comes to electrical equipment. I think the first paper I did on the first ultrasound world back in '04, it talked about using all these different technologies, and James and Chuck talked about that. You can't use just one tool. But there was a belief out there in industry back in that time period that ultrasound was useless below 1,000 volts. Would you agree? I categorically disagree with that. I find a lot of my faults at 600 volts and below. And if you're doing programs using the ultra probe and you're not taking advantage of that on the equipment at 600 volts and below, I think you're making a mistake. Technology proves useful, and it's a must for any tool. We've seen dB level. I can't stress this enough for the folks that want to do this or are doing it. Forget decibel level for severity. It only tells you how close am I to the source. And you may not be very close. That does not mean it's not severe. But even though the intensity level is low, you'll still get the data out of the time domain and FFT that you need to make good judgment calls. If you don't use both the FFT and the time domain, if you only choose to use one or the other, you will miss problems. There is no doubt in my mind. So you have to use both every single time. And becoming familiar with the types of signatures and footprints that you want to identify is critical to picking them out quickly and adding layers of precision to your judgment calls. And it's going to make you look a lot better when you're right. So like the paper from 2008, it says, the one I did last year, what you can't hear with your own ears can in fact hurt you. So be on the lookout out there and become familiar with your signatures. And that's the end of that one there. I'll take some questions.
Yeah, just now the last example you showed. So the last example you showed, that's the low voltage.
Yes.
But, you mentioned that you use contact, but such breakers like this, they are, they're numerous. Usually people don't walk in and do it. Use an airborne, to actually did a quick and find that something off before you use the contact?
Yes. Actually, on this type of equipment, we would not even open the equipment up without doing an airborne scan. But on a hermetically sealed molded case circuit breaker, typically, even if something's going on inside, you should not have airborne emissions. Now, I have run across once or twice in the past where you did, but they were so degraded and the intensity level was so high, it became airborne in that fashion. Normally, I would not ask the technicians to go down to this level using the contact module, but for training purposes, we did, and we got lucky.
So, okay, so this is really one of those. So this is really one of those cases that you just got lucky. I mean, this would not be your standard SOP.
Not traditionally. However, if I know that I have critical loads at this type of size device, I will take that extra step. This one example, we just got lucky. Please.
I'll talk real loud, sorry. What I was going to say to Terrence is the fact that those circuit breakers do have an air gap between the switch itself and the inside of the case. I'm sorry. The
wonder if
circuit
another
breakers have
Wayfinder
an
playing
air
that.
gap between the switch itself and the body, so it's on the disparity that he just detected, he might and probably would detect it with the scanning module high sensitivity.
Actually, we did. I mean, we've seen some of this like that. That's why we're kind of curious why he just jumped into using the contact. That's why.
It was more an instructional thing on this particular visit than that. Now, we have certain devices that we always use the contact module on. You know, we've chosen, if we have anything that's over 400 amps in rating, then we're always using the contact module in addition to the airborne module. That's part of our standard protocol.
But if you go back, you can play your sound.
Are you saying that something was wrong?
There's nothing wrong.
There was nothing wrong. Yes, ma'am.
En la parte de la parte de las líneas de transmisión, no,
And the transmission line,
no sé si ha tenido experiencias.
have you had any experience with a high power transmission lines?
Yes. And the best tool for those typically, if they are high in the air, is using the parabolic microphone or the long-range module. The towers require the microphone. If it's not over 60, 70 feet, you can use the long-range module that comes with the Ultra Probe.
Mi pregunta es,
My question is,
en los aisladores,
in the insulators,
normalmente, ¿qué falla ha encontrado?
what failure have you found at the insulators?
The typical failures that I have seen are related to the destructive corona that break down the insulating material and create conductive paths to ground that initially will not have a thermal signature.
Cuando ya están flameados,
When they have, when it is obvious that there is some damage?
It's not always obvious, and the idea is to find it before the damage occurs. And using these tools that we have, knowing the difference between what is normal and what has destructive components is very important to achieving that.
I just want to add to that on insulators, the center post, metallic post, over time because of the oxides turning into nitric acid with moisture, will eat away at the center metal post and the insulator could break loose over time.
You also get hairline cracks in
Yes, and hairline cracks can occur.
the insulators themselves.
Yes.
One thing that we find, that I found in Philadelphia was that one thing you find with insulator problems on high power lines is the interference in digital television and internet signals. So that'll bleed into their, these are closed systems, but they're closed more for weather, not electrical noise, and you'll get some interference in some of those things.
Yep. So you think it'll play?
One more.
One more? Please.
siempre en las líneas de transmisión, en los aisladores, dice un cliente,
Dígame la pregunta concreta, por favor.
siempre en los aisladores de las líneas de transmisión,
Always in those insulators and the high power transmission lines,
me dice un cliente
a customer tells me
que él ha encontrado una tabla
that he has found a chart
en la cual
in which
hay dBs permitibles
decibels. There are some dBs that are allowable
a lo largo de toda la línea.
throughout the entire line.
I understand the question. We have in Latin America many people.
Microphone.
Well, we have many people in Latin America that thinks that it's normal to have like a hearing sound in all high voltage transmission.
It's
Some experience with that.
I believe they're talking about nuisance corona, and that is perfectly normal, but it's not related to decibel level as much as it is the frequency content and what the time domain looks like.
And in low frequency, like just with the ear, it's normal hearing from wires and bolts.
I'm sorry?
Sharp points from wires.
Oh, the sharp points from the wires and bolts. Yeah, it can move into the audible range. And one of the things that impacts that, and I think we all know that, is humidity. So the more moisture that's in the air, you have an amplified effect that becomes audible to us where you don't even need the ultra probe to hear it.
No, not inside.
It's no failure. It's no failure.
It's not a failure. There are the occurrences are normal in certain cases. With corona, it's going to be present when the voltage levels are above 1,000 volts, and that's normal to have. It's an ionization process. The magnetic field expanding and collapsing agitates the air molecules, and they vibrate. And when they vibrate, they create the high-frequency noise that, with enough moisture in the air, becomes audible at our hearing range.
Es normal en la playa, en un ambiente húmedo
It is normal at the beach in a moisture environment
o en un ambiente tropical.
or in a tropical environment.
Yes, having lived here in Florida for 10 years, we had many transmission lines at my place of employment where the salt air contributed or increased the occurrence of corona that we're talking about, and would accelerate the failure of the insulators if they were not maintained.
Y en el trópico,
And in the tropic,
So it's the same thing in the tropical environments. You have the salt air that settles on the insulator, and that accelerates the process, which can accelerate the what's the word I'm looking for? The degradation of the insulators. Thank you. So they must be maintained. Any other questions?
I want to see the video.
Oh, that's right. We got the sound. Let's see if we can play this. Yeah, this was the first one. This was on that 13,000 volt switch in Charleston. Not something you would expect to hear, correct? So if we go to, I should have the second recording here. Now that, everybody would agree, the tonal quality changed on that, didn't it? And the other thing that I said had changed was the positioning on the switch with the module where the intensity level was at its peak. So there was a shift there between July and September, and in some ways I believe that means that it was degrading at an accelerated rate. So I'm very pleased that we found that. And see, the other one that didn't play... See if we can do the other one. This was the transformer in the UK, right? The one that had movement structurally. You hear that? It's not only the popping that you hear, but there's shifts in the intensity or decibel level as that's occurring. Now, that may or may not be related to the load demand on the transformer. I don't know that. But there was an obvious shift, even tonally, with the intensity level of that particular recording. And this was the second recording here when he went back. Doesn't sound right, does it? A lot more pops, a lot richer tone, and you heard it drop off and then pick back up. So it's getting worse, and they need to fix it, and it's all a result of that shifting.
En los transformadores, ¿cómo hace las mediciones?
How do you take measurements at the transformers?
We used, let me go back to the picture. On this ductwork going into the transformer, we took the stethoscope module and contacted both the duct and the vessel of the transformer.
¿En el área de primaria o secundaria?
In the primary or in the secondary?
This was on the primary side. But it can be used on either the primary or the secondary side. And I think all the other ones played, right?
I apologize, I had the mute button on.
See in here, I thought my ineptness with, Bill Gates' PowerPoint was shining through. Any other questions? Well, thank you for your time.